And now I'll introduce our speaker for this morning, Mike. Thanks so much, Mike, for joining us.
Thank you. Hi. Good morning, everybody. Today we're going to talk a little bit about artificial intelligence and security practitioner. We're going to look at the good, the bad, and the AI, but not necessarily in that order. So, when we talk about, we're going to look at what's good with AI, what's bad, what could actually go really wrong with AI there, and we'll kind of wrap up a little bit. So a little bit about myself. I'm a principal platform architect for Google Cloud. Came over as part of the Mandiant acquisition and came to Mandiant through another acquisition of a company called Respond Software. I've been involved in security space, security operations, a lot of time as a sales engineer, platform and system architects and so on for about the last 23, 24 years. Usual things, served in the Air Force, was 3rd Combat Communications, got my start, really cut my teeth at an old company called GTE, and have bounced around since there. Back at Open Service, which was known as Log Matrix, I helped to prototype a risk correlation engine that we built that was a little bit ahead of its time. It was an idea of stateless correlation. Worked pretty well, but the company didn't work as well as the product did. Right there. So in spare time, I like golf, I like fishing, taking up pickleball lately, like most of us old people do down in Florida, and travel, go to concerts, and spend time with the family, the grandkids, and everything else. So well, let's kind of dive in. Let's talk, so like I mentioned, not necessarily in order with the good, the bad, and the AI. So we'll talk about AI for a little bit, look at different ways that you could use AI, different types of models, things like that, and you're going to see a lot of these XKCD comics thrown in throughout here. I'm a huge fan of that one, of them. So, but like anything, we really need to have a little history and understand where AI came from. Everybody kind of thinks of AI this relatively new thing. We heard about it in the 70s in some different movies and everything, but AI has actually been around for quite a while. Actually got its start way back in the 40s, and back in the 40s and 50s even. We kind of all know the story of Alan Turing, one of the pioneers of AI out there, and it's where we actually coined the Turing test. That term was actually coined. In the 50s and the 70s, we started seeing more practical applications and less theory of AI. And of course, like a lot of things, everything tends to start out with a game sometimes. So in 1952, there was actually checkers, when a human could play a computer in checkers. Now, it hadn't quite got as complicated as chess or anything, and considering that computers at that time would take up about half this room, that was a pretty impressive feat. We started seeing a few other things. In 1965, there was something called ELIZA. It was an online, well, it wasn't online, but it was a localized computer therapist. And I used to love that game. I actually worked with a person at Verizon Wireless doing a project there who roomed with the creator of ELIZA at MIT. ELIZA would just pop up a little text prompt on a screen and say, how are you feeling today? And you'd tell it how you're feeling, and it would do the usual. Based on that, there'd be about 3 or 4 different responses. Oh, would you like to tell me more? Why are you so angry? Why are you upset? Things like that. It was actually kind of a cool thing. I think I started playing with that when I was about 9 or 10 years old. In the 80s and the 90s, we saw the rise of the machines, not the Terminators. That's going to be the 2080s. We'll get there eventually. And we started seeing things like anomaly detection start taking shape out of there. Major milestone, 1987, for those of you that might remember it. Deep Blue wins. IBM Computer actually beat Garry Kasparov, world chess champion, which was an incredible feat at the time. Now, those kind of things happen a lot. And then when we started getting into the 20s and the 10s, we started seeing a lot more with AI much later. Early on, they called it the dark ages of AI. In fact, around 2004 to 2011, you can see right there, the drop in AI searches online was greater than 50%. It's kind of a dark period. Nobody really knew much, did much, cared about it. We had too many other problems we had to face. And then we started thinking and seeing AI move into the mainstream a little more. Started being the voice assistants, the Google Assistant, Alexa, and Siri, and so on. And then we started seeing the rise of deep learning. So we kind of started seeing some progress, and now to where we are now. But one of the biggest things is in AI, we see a lot about machine learning and we see a lot about AI. And sometimes we confuse them. And machine learning is really, as we should know, a subset of AI. So AI when we use that term artificial intelligence, we're talking more about a very broad field of technology. So, with building machines, building computers. Ultimate goal, we're trying to mimic cognitive functions that are associated with people. How would a person answer this question? What would we find for a pattern in here, and so on. And commonly, we're using AI. Really, we see it a lot, especially with generative AI today. We're really summarizing or generating information. So summarize this threat report for me. Summarize these findings, or generate a picture of penguins in a tuxedos, as my kids like to do all the time, and then send them to me and they think it's funny. Machine learning, just a subset of artificial intelligence. So what we're really doing there, we're trying to teach a machine to actually learn, throwing data at it and saying, find an answer here. It might be labeled, might be unlabeled, and so on. But not just find an answer, but learn as you go along so you can make smarter and better decisions. Now, it comes to machine learning, we usually see two types of machine learning. It's two types. We've got supervised machine learning. So in supervised machine learning, we're using labeled data sets to actually train those models to understand that data. And we want to be able to try to predict outcomes. For use cases on that, you're going to see things like spam detection, because we can label emails as spam, and then we can try to find those characteristics. Or sandboxing. We know generally how malware behaves, what we're looking for, so it can find it. Unsupervised machine learning, on the other hand, this is basically analysis of unlabeled data sets. So you can often throw things like your logs at unsupervised, and looking through, finding patterns. What's not normal? Something in here is not like the others. If it's abnormal, could very well be an indication of a breach or some type of a problem, or new behaviors. New files are actually, new executables, new files are actually running in your environment. So we can use unsupervised. And you're going to see a lot of these terms as you talk to vendors, and everybody really starts to double down on AI. Now, when we get away from machine learning and go back into AI, there's a few different things there. One of the first, and we're seeing a lot of deep learning. So in deep learning, you're really trying to leverage neural networks. A neural network is actually trying to mimic the function of a human brain, trying to get you to think exactly like a human, exactly like a person does, to really draw connections between maybe even disparate sets of data, perform actions, things like that. So in this case, trying to actually recognize suspicious behaviors. Behaviors are a lot different than looking at a log and saying, oh, okay, I have malware here. I have a file that's matched a bad hash. I've got an IPS signature. Somebody failed to log in. When we're trying to actually look at behavior, it's, okay, this user logged in, it's probably nothing anomalous about that, but what's their behavior? What are they doing next? What is this software going to do next after it's been installed? Trying to distinguish that from normal, and then saying, okay, this is a little bit, this is abnormal. So, and then reinforcement learning, another one that we're going to see right there. So that really focuses on, in highly dynamic environments. One of the use cases mentioned there, autonomous intrusion detections, automated response and threat hunting and everything. But you're really learning like a person does through trial and error. Is this the right answer? Nope. Okay. I may not know the right answer, but I know the wrong answers. And a lot of times, like Edison said, he didn't fail 400 times or whatever the number was when he went to invent the light bulb. He just discovered 400 ways not to actually build a light bulb. So all through trial and error, a lot of things come out that way. Use it in threat hunting as well to try and figure out and understand where the actual threats are, where that behavior is different, where the suspicious files, patterns, and so on are in that environment. Then we get into a few other pieces. Natural language processing and neural machine translation. So natural language processing, it's a field of study where what we're trying to do is not just look at an email, look at communication, look at things on Telegram and so on, and understand, look at the words. The problem is language is very nuanced. What's the sentiment? What's the intent of the language? What's the tone? All of that can actually matter and distinguish between malicious behavior and non-malicious behavior. There, you see a lot of that type of thing. So we use that, trying to find malicious activity in botnets, seeing fake accounts, looking for bots on even social media, things like that and everything, but understanding what might be a fake account, what might be a real account, what their sentiment is when they're saying something that they're going to take this company down. Do they actually mean that? And it can go a little deeper than that. Then we got neural translation. So neural translation is actually translating text from one language to another. We've seen a lot of Google Translates and so on out there for a long time, but again, especially in security, that language becomes really nuanced, and it differs from discipline to discipline, differs from person to person, organization to organization. So really trying to understand that language and understand what the intent is, what the activity is inside of that digital content. Really communication between two people is what we're really looking at more there, or two or more people actually with that. And then this is the big new hot one that we see everywhere. I just liken it to every conference when you go to, an RSA or something every year. A couple years ago, it was all about XDR. That's all you saw plastered everywhere. Every bus, every vendor had an XDR story. Now every vendor has an AI story, and every vendor talks about generative AI, how we're going to use that, implement that into our products, the benefits of it is. Well, that generates content. So it's going to generate your images, pictures of the penguins, that I seem to see almost every single day out there. Generating videos, generating documents, generating scripts. A lot of us here have used Gen AI to write a quick script. Just simply ask your generative AI of choice, your Bard, your Chat GPT, write me a script that can clean up a file system when I've got 10% of free space left, and boom, it's going to pop out a bash script. May or may not be so accurate, but it's a good starting point. Saves us a lot of time. Saves us a lot of work, and more importantly, can really make us a lot more efficient as practitioners when we start leveraging generative AI. Where are we going to leverage that in security? Well, summarization. Go into a product like Mandiant Threat Intel or any other threat intelligence product. Go search for an actor, an adversary, a file hash, and get information about that. And pages and pages and pages, everything that you've got to summarize, everything that you've got to look through and read and try to find out, is this actually relevant to my organization, something I can use? Do I need to care about this? Should I be worried about it? Well, instead of having to read through 40 or 400 different pieces of information, generative AI will summarize that information for me. Generative AI will tell me, this is who this actor is, these are the type of industries that they target, these are the typical IOCs, the typical attack vectors they use, etc. Now that's all summarized, and having to try and search and find it speeds up and helps you make that decision if that information, you need to use that in threat hunting or anything else associated with that. So synthetic log generation. Another good use case for generative AI. You write a correlation rule, trying to train models for certain things. You can use generative AI to actually generate the logs that you actually need. Instead of, we've been there, I've done a lot in my career writing correlation rules and content where trying to capture a specific type of attack scenario, trying to trigger those logs, and we don't always have the logs that we need. So we go and we say, all right, here's my IPS, I grab some raw logs from it, and then what do? Dump them into a text editor, and I look at them and I think, okay, wait, I need this signature, I need these IPs, or and then we write little scripts to replay those logs and so on. And have somebody do that for me or do 90% of the work or something, say as not a person yet, that can be incredibly helpful as well. So there's a lot of ways to use generative AI besides the way that you see a lot of people using it out there. So one thing to kind of keep in mind. Then let's talk about the good. The divider subhead should not be there. That's not some sarcastic subheader or anything like that. That was me not hitting a delete key right there. So when we look at what's good with AI, one of the things I like to focus on a lot is talking about detections. And when we think about detections in security, and specifically in security operations, think back, lots of correlation rules. Everybody has written correlation rules. We have tons and tons of rules. And with correlation, regardless of how fancy it tries to be, what I'm really trying to do is prove a relationship between two or more dependent variables. There is a book called Spurious Correlations. It was not written by Ronald Coates. It was actually written by Tyler Given. Spurious Correlations. And he sets out to prove, when we had all this correlation hype back years ago, that you could correlate anything together. The book is full of charts and stories and data that explain these types of things right here. So you can absolutely correlate worldwide non-commercial space launches with the number of sociology doctorates awarded in the US. You can see that there is a relationship. There are other statistics in there that, some of them are unbelievable like this. Some of the charts are very believable, that mozzarella cheese consumption and PhDs in computer science are directly related, actually. The more mozzarella we consume as a country, the more and more PhDs we have for computer science majors. But that one makes sense. In college, late night, ordering pizza all the time. There's another one that the divorce rate in Maine correlates directly with the per capita consumption of margarine in Maine. As margarine consumption goes up, the divorce rate goes up. As butter consumption goes up, the divorce rate actually goes down. It's the opposite effect, which to me that makes sense. And then there's one of my favorite quotes. Ronald Coates is a British economist, and this is kind of what we would almost try to do with these types of correlations sometimes. So you remember the early days of rules correlation? It was false positive after false positive after false positive. We'd find that needle in a pile of needles maybe one time. And Ronald Coates here, he's talking about economic data, but it's absolutely true. You can torture the data and it'll confess to anything, meaning basically if I want to find a relationship between the data, somehow I'm going to find it. And sometimes we go down a path with blinders on that this is what it should be. I know this is the right answer. Therefore, I'm going to frame the problem to fit what I think is the right answer, not find the answer. We just frame it to fit our beliefs in there. So we look at AI detections. Let's look at some of the good things that we can actually get out of AI detections. And the first, pretty obvious, in my mind at least, these first two use cases. Anomaly detections. So we look at anomaly detections, we just kind of talked about that. How do we find this type of things? Before AI, before machine learning. Well, there's really a rules-driven approach like we talked about. If X and Y happen and Z happens, and it happens in 5 times in a 10-minute period, and then these 3 other things happen, let's generate an alert that the SOC will inevitably probably clear out. And back in those days, it was, if it's a false positive, I'm going to clear it out. If I don't know if it's a false positive, I'm going to clear it out because odds are it's going to happen again. So that bites us a lot right now. Processing, all that data really lagged when we got to really high volumes of data. Correlation engines had bogged down. We couldn't get as real time. We just couldn't scale to process into the gigabytes and terabytes of data that we're seeing today, and in some cases we still can't. So we have to look towards other things that can process at a lot higher levels. Things like machine learning process higher volumes. And as I mentioned, we had those very high false positive rates right there. Now after AI, now that we've seen it, what do we focus on more? We still focus on rules, and I'm not advocating for elimination of correlation rules or anything like that. Just like an antivirus, we don't advocate for the elimination of checking signatures, checking hashes, anything like that out there. That gets that proverbial low-hanging fruit out of the way. Those commodity things you can just knock out and get done, and rules give you that ability to really look at your custom content, to build that custom content specific to your environment, because every organization, every enterprise, every business has unique sets of software, unique sets of applications that generate unique logs. You might be using something from a vendor that very few other people use. You may have written a lot of your own homegrown applications and everything, and a lot of times that is your very first step into scouring those logs, into trying to find detections, is using a rules-based approach. And oftentimes it's a faster, more flexible way to do that, and it's a little bit easier to maintain. But if you can drive a lot of your other detections towards AI, get a lot of commodity detections out of the way, you can now be a lot more successful, free up your people, make them more efficient, et cetera. So looking at that behavior, that deviation away from normal, all right, I understand there's the classic use cases that, oh wait, Bob's logging in at 3 in the morning. Bob never logs in at 3 in the morning, and Bob never has a second cup of coffee, but here he is logging in. So then we said, but is that normal? Is that abnormal? So I used to travel quite a bit for work, and if I log in at 3 o'clock in the morning, all right, but I'm out on the West Coast, it's only midnight. Oh, I've got a presentation in the morning that I've got to finish up, and so on. So you have to understand that behavior and those intents, those kind of things come in. You can't really put that kind of sentiment into a rule, or you can't check because you don't have that big baseline. Is this consistent with the normal behavior that I've seen in the past? Using things like machine learning allow us to get around that and work through that problem. It's also massively scalable, as we've seen and we know, so I can reduce lag. Reducing lag, really what that means is I can start processing, getting my detections in real time, or at least near real time when we're doing that. Time is of the essence, we know that. Or it used to be not a problem if it took me 15, 20 minutes to get a detection. Now I need that quick. I need it fast right there. And I'm getting a lot less false positive rates because oftentimes when I've got that rules approach, it just triggers because something matches, but with AI, it can look and it can understand that, okay, we see this today, but we also saw this a week ago. We see this every Thursday, this happens, and it can identify that, instead of waiting on a human to identify that this one process kicks off every Thursday, fires off all these alerts that look like a threat, but it's not, but AI can learn and understand that. And of course, malware detections. This is really, I think, personally in security, where we really saw the first broad application of artificial intelligence was analyzing malware, where we were primarily signature-based on there. We'd block by signature, block by hashes, and it's with the old way of doing it, your old McAfee's, your old semantics and everything, not that those products don't have, those vendors don't have newer approaches to it, but we would see it was almost impossible to detect zero-day and emerging threats because you had a choice. If your AV did not know what this file was, you could either block the file or you could run the file, basically, or about your choices there. Most of the time, we want business to go forward. We don't want the help desk getting hit all the time because somebody downloaded something that they need to run, and that's all your help desk spends doing. So we'd let the file run, not realizing what those dangerous consequences were. Now with AI, you can actually, we're still going to, run those quick checks on there because, file is a piece of malware. Mimikatz is Mimikatz. Sure, it changes, but Mimikatz that I have a hash for, that I have, all that information for, why go through all that trouble of running through all that analysis? There's other reasons we might want to do that from a detection perspective. We just need to identify it. We need to block it. So we're able to actually do that, and that gives us that better protection against zero-day attacks, against the emerging threats, and so on. In fact, little graphic, I am a terrible, terrible artist, by the way, but this is literally almost how it would work. Not quite, I'm oversimplifying things. But AV says, is this malware? Well, without AI, the old way. Does it match the signature that I have? Does a hash match anything? All right, yeah, well, then I guess we'll block it or we'll not block it. Now with AI, I'll do that quick signature check, but and we've been doing this, like I mentioned, for years, but now I can do things like behavioral analysis. Understand, how does this file behave? Is it accessing things that it typically doesn't need to access? Why is a program that you just downloaded from the internet suddenly trying to download another program and now run a backdoor, or run a TeamViewer session, or start scanning through and enumerating all of your files? It's going to encrypt one of those days. With that behavioral analysis, with that sandboxing, we can determine what these unknown files are with a lot more success on there, and we can now warn others to prevent that outbreak. So as soon as it finds something, you can inoculate across your environment and do it fairly quickly. That'll prevent that. Our threat hunting, another great place where we can actually use AI. It's a necessary process. We know that, we understand it, but it's very time consuming and very resource intensive. And threat hunting, really, when we talk about resource intensive, it's that bottom right there. It's very human capital dependent. We have to have a staff dedicated to that. We have to have people, processes, technology, everything in place for that. Now after AI, and then what am I basically doing with my threat hunting? Well, I'm trying to figure out, do I have, form my hypothesis and figure out, have I seen signs of this in my environment? Take my list of IOCs, go hunting everything else. Kind of almost follows the threat intel piece right there on it. Well, after AI, first thing I can do is I can take that threat intel that might be my starting point for threat hunting, and now I can automate the initial analysis of that data. Now AI can actually tell me what's relevant in your environment. You know what, we see thousands and thousands and thousands of attacks nonstop. Is every one of them going to target your environment? No, not at all. Should I be worried about something that hits industrial control systems when I have absolutely zero of those in my environment? Not that the adversary doesn't do any things. We might want to worry about the adversary, but not those particular tactics, not those techniques, not certain IOCs. So we can filter that down. And it's really going to help to enhance that decision making, improve that visibility, and when we get into leveraging the threat hunting or the threat intel with the AI right there, and also look at historical patterns to produce those kind of trends that I need and start developing some predictive models. All right, this is what I've seen in the past. What can I maybe expect to see in the future out there? But importantly, too, when you take a lot of these different processes that are human capital dependent, but we're still very limited with staffs, and nobody advocates getting rid of staff. We can't afford to do that in this day and age right there. But it's going to free up the practitioners. Now what can they do? Well, yeah, they still got to do threat hunting. Somebody's got to understand the output. Somebody's got to guide the process and babysit it, if you will, and everything. But we've got a lot more complex threats that we can go and have our practitioners actually work on things that are sometimes a little more enjoyable. So this thing that I seen over the years in security operations on the human side, where if you ever see a new analyst get hired into a SOC, and they come in that first day and that first week and even that first few months, they are excited. They are, ball of energy. They're running, or they're just thrilled to be there. This is the greatest job ever. Because a lot of them, they think that they're going to fight that good fight, but they think it's going to be a lot more exciting. They think it's going to be like they see in the movies and the TV shows and everything else. And we know that that's not the case. Over time, you start to see it. It's almost like they go into this kind of pit of despair. All of a sudden, about a year later, if they're still doing that same job, you kind of see them like, yeah, time to go to work today. I guess I got to go log in and go check the SIM and check everything else that we have. Fun. It's a big attitude change that you actually see. But it's not because they're not fighting a good fight and they don't believe in the mission. It's because they're getting console fatigue. They're getting screen fatigue. They're staring at screens all day, practically looking for alerts. They're working the same thing over and over. And when your job is 90% dealing in false positives, it starts to wear on you a little bit. So you end up with about a 10% success rate, and as a person, that kind of wears on us. A little bit. So that's kind of some interesting things that you start to see after a while. So, and then generative AI, another piece to kind of talk about what's really kind of good about that. We've talked a little bit about what it does, a little bit about some use cases, and we're going to see a lot more use cases and everything come up on it. But let's look at kind of three good things that we've touched on a little bit first. Stopping threats, right there. So you can prevent patient 0, but also patient 1. Patient 0 gets that foothold in the environment. Patient 1, that's the next infection, and everything spreads from there. If you can stop patient 0, great. If you can't stop patient 0, you'd better find and prevent patient 1, somebody else from getting affected, and that malware out there, keep it from spreading. So we can leverage our AI tools to do that. A lot less toil. Systems being able to secure themselves. I found a threat, and now I can actually have my system, like in the case of an EDR, a case of an AV, suspicious processes are running. All right, well, this suspicious process, we've analyzed it, we've looked at it. You know what, this should no way be running on any machine anywhere in the world whatsoever. Let's go ahead and tell our machines to block this process, to block this file, block ingress or egress from this list of IPs or these malicious domains and so on, instead of the old process of, hey, got an alert here, I tracked it down, and I've got this domain right here. Turns out it's a malicious domain and we're letting it through. And then what do? You send the ticket, you send the ticket on, and then the security architects get the ticket and they look at it and they're like, oh, okay, we need to go block that IP and we have to, or that domain or whatever, and we go through this big process. We can automate those type of things. And really with people, we talk about not getting rid of people. Security, we talk a lot about security teams, scarce talent, scarce resources, everything. We can't find enough people to fill all the jobs that we have. That's a different problem, but when we can scale the talent using AI to automate and take on a lot of these processes that people typically have to do and take up a large majority of our day, now we get to free people up to do what they enjoy. People don't like staring at screens. Company I used to work at, we used to pass out stickers at little like FutureCon trade shows that said, "Friends don't let friends stare at consoles," and I could not agree with that more. Well, now when I don't have to stare at a console all day, I can start to do the things that humans are good at. What are people good at? We're good at creativity. We're good at thinking outside the box. We're good at finding novel solutions. Really, as people, we want big problems, and we want to be able to fix those, analyze, understand the problem, find that solution. We want to make an impact, and we feel like when we're being creative, we're thinking outside the box, we're doing something other than the quote-unquote mundane 9 to 5, we feel more valued, we feel happier. Well, now your employees are if your employees are happier, your processes typically work better. You've got better morale, everything else works across the board like that. So, and you can take, now with AI, the other thing when we're democratizing security expertise, every organization has a hierarchy. And you've got your new people, especially working in a SOC. Don't know so much, we're training them, we're guiding them, we're teaching them, they're learning, they're a good resource now, they're going to be a great resource one day. We've got our tier 2s, our tier 3s, we've got our experts. But we've also when we have it set up like that, we have to rely, we certain people become bottlenecks to solving certain problems, to securing our environment, because they cannot, because they have the expertise, but they're out today. They're gone today. Their backup's not in. Their backup's in a meeting, things like that. You've got lower levels, you've got lower level people that could do some of these things sitting on their hands because they don't have access to that information. But with things like AI assistants, they can help you. They can guide you through that space. We can leverage things like generative AI as we work through a process of remediation or a day-to-day processes or whatever that is. We can build better documentation, better tools to assist people. We can share that information, but we can do it as we go nowadays. We don't necessarily have to build a process, then build documentation and do knowledge transfer and everything. We can present the information in such a way that it's easily consumable and easy to understand. There. And let's look at the bad with another. It should be Divider Subhead 2.0, the sequel. I thought I deleted those, but I guess I didn't. So what could possibly go wrong with AI? Well, a lot of things, a little tongue-in-cheek here. So this is why you do not bring the CS department to your weekly dinner right there. You get a shot of Cheerios with vermouth, quail eggs and whipped cream and MSG, and deep-fried Skittles. But they said, don't worry, the algorithm the genetic algorithm is going to catch up to existing recipes in no time whatsoever out there. Plus, everybody knows you drink whiskey with Cheerios, not vermouth. But when we look at kind of what can go wrong with AI, a couple of different things can happen. One, your AI can be attacked. So people are going to attack your AI. If it's connected to a network, it's going to get attacked, period. There. Or the AI can attack you. And in spite of the image, I'm not quite referring to Terminator style here or anything like that. Some very simple examples we can do. So there are 3 things up here. There are icons that I grabbed somewhere and one that I do freehand. But you can probably guess which one that is. So things like AI data, so you could actually, data poisoning. We can poison these, you can actually poison these systems. This was actually done, I want to say back in about 2005, 2006. Basically, our evil villain, our attacker, composes a spam email. He knows it's bad. He knows that email's got a malicious link in it. It's spam. I'm going to trick somebody to clicking on something, doing something to gain access to their systems, drop some ransomware, something like that. And then what do? Well, you send that email to a bunch of different email services out there. You run it through a Gmail. You run it through an Outlook. Back in those days, you run it through a Yahoo, whatever, wherever you can. Run it through everything. And instead of letting the system learn that, oh, this is malicious, this is spam, you flood the system with reports that this is a good email, this is legitimate, there's nothing wrong here, nothing to see here, move along. Do that over and over and repeatedly. Eventually, a classifier could potentially mislabel that as spam. It did happen back, and I want to say it was the early to mid 2000s that this actually did happen. And then what happens when that's no longer classified as spam and it gets through and gets into the inbox? Same thing that happens to me every single year. My mom clicks the email because she wants to see somebody's vacation pictures that went down to the Bahamas, or her iCloud storage is full. She doesn't know what iCloud storage is, but if it's full, she's got to deal with it somehow. And I spend Thanksgiving fixing her laptops and the ones that my brothers bring and my aunts and my uncles and everybody else. And kind of like, I heard some laughs. I think we all know that we all end up doing that sometimes. And I just want to watch football, but can't quite do that. So what other ways can your AI be attacked? Can your models be attacked out there? Well, evasion attacks. It's kind of difficult to pull off right here, but you're actually manipulating the data during the deployment. You want to deceive the trained classifiers. Your adversary's goal in this case is to deceive those classifiers into thinking that something malicious, something nefarious, something that doesn't belong there is actually good and should be part of that set, that it's not malicious, whatever that is. Timing is everything on this one because you're going to have to, because this has to be done during the deployment of those models, during the initial training, during those initial training phases right there. What it causes, they're going to start making incorrect predictions, those models are. So you've poisoned those models in such a way that hopefully, as an adversary, you could actually control some of those outcomes that come out of those models by injecting that bad data into there. Now, you can also do what's called model extraction. This is a little different. With model extraction, they are actually trying to steal the data that you've used to train that, to train those machine language models, those learning models. Trying to extract that data. Why would they want to extract the data that you trained it on? It's just a set of data. Well, if I've extracted the data, then I can potentially rebuild that model. If I can rebuild that model, now I can understand how that model behaves, and when I've got a working copy of that model that an organization is using somewhere, I can now figure out and start to find ways to deceive that model or to trick that model. I'm not going to manipulate it with new data or anything, but if I understand the workings, I can now understand how to mask, how to obfuscate, how to present my data in such a way that the model says, okay, this is an anomaly, this is good. I'll let this slide, I won't raise an alarm or anything else. So that can do it. Another way, when you look at, so that's attacking the AI. Let's look at the AI attacks that actually come out. This is one of the things that we're seeing, and one of the things that generative AI is unfortunately going to help our adversaries with. And I know we heard talks this week, and if yesterday you were on the keynotes and the last couple of days talking about how we want to make sure that the adversaries, the quote unquote the bad guys, whatever we want to call them, there are certain nation states don't have access to this technology, or we're going to make it at least difficult for them to get access to this technology. They will still get access to the technology. We're just throwing up roadblocks, because that's going to happen no matter what. We're going to prevent a country from getting it. The country's going to set up a bunch of shell corporations that nobody can trace, talk to vendors, buy the products and everything else out there. So this is an actual email that I got. I made a reference earlier to iCloud. This is an actual email I got a few weeks ago telling me that all my photos are going to be deleted on there. Now, most people look at this and say, all right, this probably doesn't look too real, but enough people do, and we've got a nice little update my payment link right there. So when we update, but generative AI can make this a lot easier, and a lot of times these emails are this poorly written. One, it's that idea of throwing something against the wall. Sure, it's a badly written email, everybody knows it looks bad. Send it out to 2 million people. People are going to click on it. Send it out to 100 million people. Even more people are going to click on it, and so on. With generative AI, I can take that same thing. I actually asked a generative AI to write an email telling me that, write an email to tell my customer that their storage is full, and their email, and they're at risk of having their photos, their memories, everything else deleted. And it put together not only did it put together a great email, even told me, update your billing information, put your link to the billing page right here. Sincerely, the company name team, so the Apple team, the Google team, the Amazon team, the Microsoft team, whoever that is. It gave me a lot of nice helpful suggestions. How can we make this email even better to really reel them in right there? Explain why it's important so you can continue to use the service, and even better, your adversary, your hackers aren't going to think of this. Offer a discount on a storage upgrade. No, let's make, if we're going to steal their information, let's make sure we really hook them in. So generative AI is really going to give our adversaries an edge in social engineering, and we've already seen a lot of that with deep fakes and with the deep fakes out there and everything. The phone calls. My mom actually called me a few days ago, and she asked. I've got a son named Justin. She goes, "Is Justin in jail?" I'm like, "Not that I know of." She said, "Well, I just got a call, and it said it was him, and it sounded like his voice." She's in her 80s, so I'm not sure how much exactly it sounded like it, but she said it sounded like his voice, and he sounded upset. Said he needed bail money, that he was in jail. They even had the county that he lived in correct on that. I'm like, "You did not bail him out of jail, did you?" And she's like, "No." So thank God. For other reasons, I wouldn't want her to bail him out of jail either. But as the AI attacks us, because you got to learn your lesson. AI generated manipulated video right there. So we're going to generate realistic videos out there. We've seen all these deep fakes everywhere. It's interesting. There's a lot of news stories about these type of things with the generated manipulated video, the deep fakes and the voices and everything else, and that this is going to be the absolute doom and gloom of the world here because our adversaries can do this. But when we look at how this is really being used out there in the world today, go to Instagram and just start scrolling through Reels, and nothing to really actually worry about. And we've even seen this in things like the Dragon Bridge campaign, which was a realistic-looking deepfake video of Zelensky talking about Ukraine and Russia and the war ending and Ukraine surrendering and everything. So we see a lot of those types of things. Then we can improve. They're going to improve social engineering quite a bit as well with this. So not only can they just use some generative AI and say, here we go, let me get you a better letter, get somebody to click on this, or do a deepfake or anything like that. But what about the information they steal? We see these record breaches, 38 terabytes of data here, 200,000 credit card records or 1 million credit card records, 5 million social, the list never ends. Well, add on to that documents that get stolen from governments and corporations and utilities and everything else. Our adversaries are potentially sitting on large amounts, into the petabytes and petabytes of information that they have stolen, data that they have exfiltrated out of there. Everything, everything as I mentioned, from PII for people to healthcare records, all the way to government secrets, everything else. But what do they do with that information? How do they actually go through it and know what information they have or anything when we're talking billions of pages and petabytes of data? Well, guess what? Let me use some machine learning. Let me process, let me analyze this, let me categorize it, let me figure out what data is here. Makes it a lot more efficient to now turn around. If I've got credit card information, for example, I can start going through that, figuring out what data legitimate, what's good, classify that, all with AI, bundle it up, and now I can start to try to sell that quicker on the dark web or sell it to other organizations, or understanding out of a huge trove of documents that we just took, that we just stole from an organization or we just exfiltrated, what in there is actually good and worthwhile? Your HO, look, I stole the HR handbook, and toss that one out. But I don't have to have a person or armies of people going through this data. I can now classify it and figure out, okay, what do I have that's confidential? What do I have that's really important and what not out there? Like we mentioned, personalizing phishing materials right there. Everything. And prompt injection attacks into large language models as well. How can I, what can I actually do to get these models to behave the way I need them to behave? I'm going to do that through some prompt injection attacks. And then the last one, this isn't necessarily AI attacks, this is more like the human element on the AI side right there. I think, what could actually go wrong? Well, that would never happen, right? Nobody's going to go into Gen AI and nobody's going to say, can you summarize our pen test findings from this report that I'm going to upload? And they're not going to do this in the confines of your enterprise or anything else. They're going to do this on a Sunday because they've got a meeting on a Monday morning that they've got to go over and do the details of this report. So they're going to do it on a commercial one, and they're going to put that information out there and potentially put your organization at risk. Then you say, well, that'll never happen. My people are smarter, my people are better than that. I remind you way back when the Target breach happened, and screenshot from an actual website right there that almost everybody got that link for right there. They were nice enough to create a website. It even was encrypted and everything else. Well, all I had to do to determine if my card had been hacked and my card had been breached, I just had to go to this random website, enter my credit card number, enter my CVV, and it would tell me if it was in there. The answer every single time if you put something in there was no, by the way. Why would it be no? It does sound kind of humorous, but think about it from an adversary. If it comes back and says yes, I'm a person that actually believed that this was legitimate, did that, what am I going to do? I'm going to call my bank, call my credit card company and say, oh my God, my card was hacked. I found it in a database online. I need you to shut it down right now. But probably 2/3 of the people that get a response back that says, nope, your card wasn't there, they're just going to be like, oh, okay, good. I can go keep spending money until the card gets declined, because you don't have it anymore there. So it's going to affect, so there's a lot of ways that, and there's a lot more than this. So lettering blended in. This is supposed to be an Alan Parsons reference, not an Alan Parsons from Austin Powers, but where do we go from here now that all our AI has grown up? It's an old Alan Parsons song right there. So where do we go? What do we do? What are our parting thoughts? Kind of, what can we do? Well, in your organization, you're going to go down this AI journey, and everybody pretty much is. And rather than just grabbing at the latest shiny toy, first and foremost, identify the gaps in your environment. What are you currently struggling with that you think AI can actually help with? Do you have blind spots in your monitoring? Do you have processes that you feel could be improved with AI and so on? You've got to figure out what those are. Then start building use cases around what can actually help you close those kind of gaps. You know, am I struggling with detections there? Am I just struggling with actually, you know, stopping and preventing threats right there? Well, you know what? I could use AI to actually, you know, actually do that, help that. Or do I need to deploy machine learning? Is it not? In fact, I'm getting hit with the threats. Is it because I can't prevent them, or is it, you know, because I can't even identify what those threats are? There's distinctions between that and how you're going to actually use AI. So you need to understand, you need to figure out what use cases are there, and then analyze your existing platforms. New features, new tools all the time. Is there anything in there that you're not using? Is there some machine learning there that you haven't used or haven't trained properly or anything like that out there? My existing tools have some new features coming out. Good time to examine the market. Are there vendors out there that are putting purpose-built AI for reasons and not just for marketing into their solutions there? Or do you build or buy? That's a whole nother decision, and that would end up being a whole nother talk. So, and then these resources, of course, are a little biased working at Mandiant here, but a couple of different really good ones to read right here. And you just go to mandiant.com under resources, the blogs. You'll see all of these right there. So looking at the good side, how can AI help you? It's a great blog, great paper there on how Mandiant is leveraging AI with a lot of ways that you can apply that inside of your environment right there. It's a really interesting read on the bad right there. Threat actors, generative AI. What can they do with it? What do we expect them to do in the future? Out there, and then that same one on leveraging AI also has a lot of good underlying information on AI itself to help get a little more information out of there. Well, looks like I hit it right on the mark. It's that is the 45 minutes, but that's so. Thank you very much. I don't think that we have time for questions because we got to turn the room over. So.